Hi, welcome to my second video on the Rust programming language. In the last video, we covered installing Rust and creating a Hello World program. In this video, we will take a look at a tool called Cargo and also learn about variables in Rust. Now, in our last video, when we made the Hello World program, we did everything manually. First, we created a file using the touch command. Next, we wrote our Rust code in the file using a text editor, then compiled it using the Rust compiler, and finally executed the resulting binary. But that's not how we do it in reality. Instead, we will use a tool called Cargo. What's Cargo? Well, Cargo is the official Rust build tool and package manager. It's a very useful tool that helps us create projects, manage dependencies, compile projects, and also distribute them. It automatically compiles and links all the various dependencies in our program and also helps us run and test them easily. Now, let's see how we can use Cargo. The first thing we need to do is to create a new project. To do that, we can use Cargo new. This command prompts Cargo to create a new project which is specified by the new subcommand. We also need to provide a name for the project at the end of the command. I will call it hello_world. Once Cargo finishes creating the project, we have to navigate into our newly created project directory using the cd command. Type cd and then the name of the project we just created, which in my case is hello_world. Then we can run the project using Cargo run. Cargo compiles our project and then executes the resulting binary, which in turn displays hello world in the terminal. It gives this output because when we create a new project, Cargo automatically generates a main.rs file and includes some boilerplate code as a starting point. By default, a project created using Cargo will have this directory structure. Here we can see that there are two files in the root directory, namely cargo.toml and cargo.log, and also an src subdirectory. Further inside the src directory, there is a main.rs file. This file is the entry point of our program. Without it, our program will fail to compile. I will explain about the other two files sometime later. Okay, so now that we know how to create and run projects using Cargo, let's move on to the Rust syntax. The first thing we will learn is variables. We will see how we can create them, set their value, and also how we can mutate or modify them. First, let's see how we can create or rather define a variable. To define a variable, we need to use the let keyword. Every variable has an identifier which is commonly referred to as the variable name. So when we use the let keyword to create a variable, we need to provide a name for the variable as well. I will call this variable x. Now, we defined a variable named x, but currently it does not have a value. We can fix this by initializing this variable to a value, let's say 0. So what this will do is it will create a variable named x and initialize it to 0. Now, we have created a variable, but it actually doesn't do anything yet. So what we are going to do is print out this variable to the standard output. We can print it using the println macro, which I talked about in the last video. But there are some slight differences compared to what we did last time. Last time, we just entered the string we wanted to print inside the double quotes. That works for strings, but not quite for variables. If we want to print variables, we need to format the string. Now, formatting strings in Rust is pretty similar to what's done in other languages like Python. To format our string, add a pair of curly braces inside the double quotes. Next, we need to pass in what variable we want to print as a second argument to the println macro. Put a comma next to the quotes and then type in x, the name of our variable. If we now run our project, it should print 0 in the terminal. Okay, so now we can declare a variable and also set its value. But it would be great if we could change it, right? That seems easy. Just put x equals 1 after we declare the variable, right? Well, not quite. If we try running the code, it won't compile and will give this error. This error occurs because any variable in Rust is immutable by default, meaning that they are constant and their value cannot be changed after they have been assigned. If we want to change the value of this variable, that is mutate the variable, then we need to tell the compiler that this variable is mutable. To do that, we can use the mute keyword. So to make the x variable mutable, put mute after the let keyword, like so. Now that x is mutable, we can change its value or rather mutate it. Let's try running our code again. It should work this time and it will print 1 to the terminal. Now that we understand the concept of mutation, let's look at another scenario. Sometimes we don't know what value to initialize the variable to, or we just don't want to initialize it to a default value. That's simple enough. Just don't initialize it to a value, right? Well, not quite. As I said in my previous video, Rust has a very strict type system, meaning you can't just define a variable like you could in Python. You need to explicitly tell the Rust compiler what type of variable you want it to be. Then you might ask, but we didn't set any specific type when we declared x the first time, did we? And you'd be partially right. Yes, we didn't set a hard-coded type, but since we initialized it to a value that is 0, the Rust compiler inferred the type to be an integer. When we remove the initial value, the Rust compiler doesn't know the type of the x variable. It could be an integer, a float, a boolean, or even a string. In other words, it could be anything, and the Rust compiler will not allow us to create a variable if its type is unknown, since it affects the integrity of our program. That's why we need to specify the type when we create any variable. Some basic types in Rust are integers, floats, strings, booleans, and vectors. First, let's talk about integers. Integers represent any number without a floating point, also known as a decimal point. In Rust, there are two primary categories of integers: signed and unsigned. Signed integers can represent both positive and negative numbers, whereas unsigned integers can only represent non-negative numbers. These integer types come in various sizes measured in bits. This basically defines the highest and lowest numbers the variable can hold. I8, I16, I32, etc. are for signed integers, and U8, U16, U32, etc. are for unsigned integers. Next, let's look at floats. Floats are used for representing decimal values. So whatever number you can't represent as an integer, you can represent as a float. Similar to integers, floats also come in sizes, but there's a key difference. In the case of integers, the sizes represent the maximum and minimum values the variable can hold. On the other hand, in the case of floats, these sizes determine the precision of the float. There are two sizes of floats, F32 and F64. F32 has 32-bit precision and F64, as the name implies, has 64-bit precision. Now we are going to look at strings, one of the most important and primitive data types. Strings are represented by computers as an array of characters. There are two types of strings in Rust, string and str. String is a dynamic and mutable data type used to store sequences of characters. It can grow or shrink as needed, allowing us to modify its content by adding or removing characters. On the other hand, str represents a string slice, essentially a reference to a sequence of characters often stored in another data structure like a string. Unlike string, and str is static and immutable, primarily used for reading and processing text without altering the original data. Next, we will take a look at booleans. Booleans are one of the primitive data types that are found in any language. A boolean represents a value that is either true or false. In Rust, we can define booleans using the bool type. The final data type we will look at today are vectors. A vector is a dynamic structure capable of storing a list of elements of the same type, such as a vector of integers or a vector of strings. They are declared using the vec keyword, and the type of the elements are enclosed in a pair of angle brackets. For instance, to create a vector of integers, we can write vec i32, which generates a vector containing 32-bit signed integers. Vectors are mutable, allowing us to add, remove, or modify values within them. Now that we know the basic data types in Rust, let's see how we can set the type of a variable. To set the type of a variable, put a colon next to the variable identifier, that is its name, and then enter the type. I will set the type of the x variable to i32, which is a 32-bit signed integer. If we modify our old code like this and then run it, it should compile without any errors. It will also output 1 since we are printing the x variable. Now we will take a look at arithmetic operations involving variables. The first operation we will do is addition. First, let's initialize x to 16 so that we have something to do the addition on. Then let's mutate x and set its value to x plus 4. What this will do is it will fetch the previous value of x, which is 16, add 4 to it, and then set the value of x to this sum. So the output will be 20. Next, let's try subtraction. To perform subtraction, we can replace the plus with a minus sign like this. What this will do is it will now fetch the value of x, which again is 16, subtract 4 from it, and then mutate x and set its value to the difference. This will give us an output of 12. We can also do operations with two variables. First, let's make x immutable again since it's no longer necessary. Let's also remove the second line where we are performing the operations and also mutating x. Now, let's change the value of x from 16 to 1024. Next, let's define another variable named y and set it to 32. We will create one more variable called z to hold the output of the arithmetic operations. Let's first try multiplying the values of x and y. To do that, type in x, then the sign, and then type in y. We also need to change the value we are printing in the println macro from x to z. What this will do is it will multiply the value of x, which is 1024, with the value of y, which is 32. This will output 32,768. In a similar fashion, we can perform division. For division, replace the sign with a slash sign. This will divide the value of x, that is 1024, by the value of y, which is 32, and then set the value of z. The output of this will be 32. That should be everything you need to know to get started with using variables in Rust. In the next video, we will see how we can define and use functions. Thanks for watching.